So this is your tutor, Mr. Mamba. So back to business, we have this question for physics third year. So this question is coming on the Wheatstone bridge. So the figure below shows a Wheatstone bridge. So this is the Wheatstone bridge, which is in parallel. So now what we need to understand is that for us to answer this question, we need to check if this bridge is balanced or unbalanced. So we proceed with that. Solution. So first we check if this bridge is balanced. How do we check if the bridge is balanced? So we have this resistor which is there, resistor BA, resistor BC, and also we have resistor AB and resistor CD. So now for us to check this, we are going to form something which will be in form of ratio or in form of fraction. So we'll start with that. We say resistor BA. So resistor BA is over this resistor BC. Then we come to here as well. We say resistor AD over resistor CD. So let's substitute the resistors. Where there is resistor BA, we substitute 8 ohms. Where there is resistor BC, we substitute 16 ohms. Where there is resistor AD, we substitute 12 ohms. Where there is resistor CD, we substitute 14 ohms. So now, in this case, we can cancel that there and there. Then try to compare. So 8 can go into 16. How many times? It's 2 times. So this becomes 1 over 2. Then we come to this side as well. We try to reduce. So which number can we use there? So we can use 2 into 6. 2 into 12, there, that's 6. Then 2 into 14, that's 7. So as you can see, this ratio which we have 1 over 2 is equal to 6 over 7. So as you can see, this is not the same. So you conclude to say the bridge is unbalanced. So what happens if the bridge is unbalanced? Which means the current through this branch, which is AC, it will flow. So that's the key concept which is there. So we say the currents at the branch AC, it will flow. Okay, so I can create some space. We calculate some analysis. We have understood that this bridge is unbalanced. So we need now to come up with the total resistance as well as the total current. That's why now we can calculate the currents flowing through the point CD, BA, and as well as to BD. So let me just create some space here. Okay. Right. So now we find the resistance now. So we say resistance, we say total resistance. So we have this branch which is here. So we can name this as our resistor 1, resistor 2, resistor 3, then this is our resistor 4, like that. So we say resistance resistance total is equal to resistor 3 times resistor 4 over resistor 3 plus resistor 4. So what is our resistor 3?
120.
It's 12 times resistor 4, it's 14. Yeah. Over 12 plus 14. So just waste this. When we multiply this 8 times 16, we get 1.8 over what is 8 plus 16? We get 24. Like that. So now we divide 24, 1.8 divided by 24. What are we supposed to have? We are getting 5.33 ohms. So this is for the first, for this branch B, A, C, B. Then we come to here, 12 times 14 is 168 over 12 plus 14 is 26. Yeah, okay. Then what is 168 divided by 26? 168 divided by 26, we are getting 6.461. Okay? 6.461 ohms. So there, what we'll do, let us now calculate the total resistance. So we are going to add this and also that. So we say resistance total equals 5.33 ohms plus 6.461 ohms. That's so when we add this, we are getting 11.794. Thank you. 11.794 ohms. So this becomes our total resistance. So now, since we have this total resistance for all this circuit, the entire circuit, this is our total resistance, 11.794 ohms. So now we need to calculate the total current. So as we know that a circuit in parallel, it shares the voltage. The voltage is the same, but the current is different at each branch. So the current here, the current there, the current there, it should be different, but the voltage, it's the same because the circuit is in parallel. So now let us find the total current. So I'll just use this same space. I want you to understand what is happening here. So current total current. So we say current total, which is IT. So current is equal to voltage over resistance. So now the resistance is the total resistance which we are going to use. So this formula is coming from Ohm's law. So the voltage is 120 volts over the resistance total is 11.794 ohms. So what are we getting, ladies and gentlemen, when we divide 120 divided by 11.794 ohms? What are we getting? So thank you, we are getting 10.174. So 1746 ohms. Oh, sorry, amps. We are finding the current. So the units for current is in amps. So since we have the total current, then we can proceed. So this total current is the current of this circuit, the Wheatstone bridge. But now they want us to find the current flowing at this point, BA, BC, AD, and CD. And we are saying that since this is unbalanced, the current here at this branch, it will flow. So now let us now understand how we can calculate now the current at each branch.